Okay. So good afternoon, everybody. My name is Esteban Juan, and I am a senior mechanical engineer at University of Puerto Rico Mayaguez, and I am an NCAS research fellow. And me and a group of colleagues have been tasked the development of an autonomous surface vehicle for acoustic and optical remote sensing of the marine environment in La Marguera, Puerto Rico. As part of the NOAA EPP and MSI mission of preparing students for the NOAA workforce, this project emphasizes a lot of different technologies and applies them and all relevant mission and be able to spread this type of knowledge with this platform. So going over the presentation, we're going to have the assembly, the wiring, and the data acquisition, the results, and the next steps that will be realized. So here we have a drawing of the autonomous surface vehicle. It is consisting of a poles, differential thrust design, a pelican case for modularity. In this case, there is a large amount of space in which ample electronics can be mounted. It is a platform in which any sensor for various oceanographic parameters can be added or taken removed from. So in our case, we have a transducer. We can add cameras, we can use AI, we can utilize different relevant oceanic parameters for any type of sensor and any different environment, saltwater and freshwater. So here we have the way that we assembled the holes. First, we started with designing these in Fusion 360, so it's a CAD software. Then we 3D printed them using slicing SBS plastic and putting them together with 5200 silicone. Layering them with gel coat and a coating of marine acrylic paint so that it is seaworthy. In our case, we're testing in salt water, and it's not a friendly environment to be in, so the materials have to be as strong as possible. So here we have the components in which the protective mounts will be, the protective case will be mounted on. We are utilizing Builda aluminum parts due to their modularity, and we were able to find them because we were doing this during peak pandemic times too. There were large supply chain issues. These were easy to follow, and since we are doing like an optional guide on how to do this type of vehicle and heavily documented, this is this option that I decided to take at the moment. But this is not like the exact core of this project. So we have the T aluminum brackets for the bridge deck platform, and which we utilize are called GO rails. That's where we mount our T200 thrusters from Blue Robotics. Allow us to control the ASV autonomously. So here we have the electrical wiring and the control system. Schematic, basically we have a very brief overview of what is going on here. We have a 12-volt battery in parallel configuration so that we can maintain all types of communication going, even if the thrusters or other parts of the system fail. There will always be communication with telemetry radio and so we can make sure that we can localize it. So we have a depth sounder, a Raspberry Pi, which is our computer for data processing, autopilot module, our power management board basically controls our speed controllers and supplies voltage to all the other components, and our Okay, so this is the main part of our project with the So this would be the main part of our project, which is data acquisition platform that we realized, just utilizing Linux-based Python programming platform so that it would be as accessible and easy to use as possible. I did not. There we go. So basically, for what we utilize for the transducer, which is an acoustic sensor, is basically make sure that you have your relevant data points. We utilize this using an MEA cable, which is what the sensor that we are utilizing sends our information as. We parse it in the computer, it gives us a CSV value, and then generate a 2D and 3D bathymetric map. In our case, this part of the data acquisition is also part of the whole concept was to make this as easy as possible for the user. In our case, we have SSH, wireless, and Bluetooth connections for the boat, so we can connect it over Wi-Fi. We can change stuff in the programming, and we can collect our information and data from it as easy as possible. So this was a key concept that we had in mind while designing this product. So here are results. This is our boat in action in La Barguera, Puerto Rico. And over there, we have a screenshot of what would be our autonomous route, utilizing our ground station to ground control. This is our basically interface with the computer to the boat, so we can program the missions. And in this case, we did a small survey of a marina, Rojo, to make sure that we had the correct parameters for mapping. And this is our first test in 2D mapping. We did one of them, and we did one of the small bay that was seen in the picture in La Barguera. And our next step is turning an L2 fish commercially available paddleboard a longer range version. We're using high efficiency solar panels, stronger compressors, and other sensors for satellite validation and calibration to make sure that the measurements are adequate. This will be the ASV. And thank you for your time.
Yeah.
Right ahead.
So there's a poster that has this on it. Is that?
Yeah, that's one of the same ones. Yeah, I was also gonna tell you guys to pass by the poster. A little nervous and presentation. So I want to do it in a little bit more detail. I feel like 10 minutes is not enough to explain everything that we have done on here. So I'll gladly answer any questions. Yeah.
How did you settle on that design for your project? Did you have references, or did you go from scratch?
In particular, saw what was commercially available and saw that it was the most viable and most efficient with a lot of technology, and you can't really add much more onto it. Here you have a variety of sensors. You can add FLIR, you can add ultrasound, you could add cameras, you could add a whole array of different things and program them yourself. And so this is more of like a baseline, so people can really follow those steps and do it for their particular uses. So in our case, we're utilizing it to map like the activity of boats in bioluminescent bay in La Barguera, see what effect it has, because in that particular place, the shape of the bay is what keeps it bioluminescent and keeps water flow favorable, that environment favorable for those organisms. Yeah.
So, I mean, this is an autonomous vessel, but it looked in your wiring diagram that you had RC controller.
Yeah, that's the override. That's like docking and everything. So typically you just program a mission, and then what the plan right now is to add object detection and avoidance, so we can program certain subroutes. In our case, in La Barguera, we have sargassum patches that can affect like the functionality of this. So we add like an override function from the computer to the autopilot to say, hey, want to round this from this input camera, and then keep going. So it does have that CRC override is basically just for like ease of use and handling.
So what would the sort of extent of the planned missions be as far as geographic extent?
As long as the batteries last, if solar panels run it during the day, you can practically run it all day. And then right now we're running a little heavier batteries with not that much capacity, just for like safety. But if you add lithium batteries with a higher capacity and that are lighter, can make a pretty big battery bank array that can last day and night if you add a solar panel to it. So yeah. Any other questions?
Yeah, there are some research being done and presented here in the conference relating to water sediments that build up during or after flooding events. Could a similar system like this be implemented perhaps to conduct different measurements or field measurements about sediment accumulation on the water floor?
Yes, of course, this can not only be used for saltwater applications, it can be used for freshwater basins too. In that sense, to see what effect it has. Our case, that bathymetric map, if you have the depth of the basin that you are measuring, if you have accurate data, you can estimate how much water you would have in that basin and see how much it has changed from previous historical data. And all you would have to do was program a route and just press a button and it will be done. Yeah.
What's the number of your poster?
114. Yeah. Anybody else?
Nice job.